Hey guys, we've got some boxes here. They're growing and somebody somewhere wants me to create a quadratic equation to represent these figures. The purpose of that is so that I can be like, all right, what's figure 200 gonna look like? And I won't have to draw a bunch of these. I'll just be able to plug it into that equation and tell what it is. Okay. Now I was doing problems similar to this with my niece the other day, and I'm not gonna lie, when she first showed it to me, I was like, I don't know how to do that. But I didn't say that. I went to YouTube and found a really awesome video that helped me figure out how to do this. I'm gonna link that video in the description. I'm not copying it, obviously, but it is where I got a lot of information from, so I did want to give him credit there. All right, so as we are looking at this, the first thing I want to do is kind of just take a mental note of what's happening. All right, so when I say that, what I mean is I'm noticing I have a rectangle in here that's 1 by 4, right? And then there's a box on top and bottom. All right, then when I go to the next one, I notice that the rectangle got bigger, right? And then I still just have a square on top and bottom. Again, rectangle got bigger, square on top and bottom. So that is what is generally happening here. So if I were to think about what is coming next, like in figure 4, 5, 6, 7, however many, I can just kind of generally figure that it's going to be a rectangle, right, of whatever size. I'm going to put some dotted lines because we wouldn't know exactly the size depending on what the figure number is. But it's going to be some sort of rectangle with a box on top and a box on bottom, right? That is going to be, we will call it figure X, right? Because I want to be able to plug in whatever number I want and get how many squares there are, right? All right, the next thing I'm going to do is I'm going to make a table that represents what is happening with these figures and how they're growing. So we are going to have our table X and Y. X is going to represent the figure number. And Y is going to represent the number of squares in the figure. So, for example, figure 1 has 4, 5, 6 squares, right? Figure 2 has 1, 2, 3, 4, 10, 11, 12. Figure 3 has 3 times 6, 18, 19, 20 squares. Okay. So as I'm looking at this, I notice, well, actually, I'm going to label my dimensions first. So the rectangle in here is 1 by 4, right? That is that rectangle there. And then I've got one guy on top and one guy on bottom, right? My next one is 2 by 5. And then I've got my one guy and my one guy. And this last one is 3 by 6. And I still have that guy and that guy. All right. So one thing that the gentleman who made that video that I linked below said is a lot of times we try to relate figure 1 to figure 2, figure 2 to figure 3, right? And it's a good effort, but what we actually want to do is relate the figure number to the dimensions, okay? And if you're like, what on earth are you talking about? Hang with me. So if you notice, figure 1, this side has 1, right? And figure 1, the top has 4. On figure 2, the side is 2. Oh, look, those match, those match, those match. Okay, I'm starting to notice a little bit of a pattern, right? Now, if I look at the length here, I've got 4, 5, 6. They're growing by 1, right? So 1 relates to 4 if I add 3, right? 1 plus 3 gives me 4. 2 plus 3 gives me 5. 3 plus 3 gives me 6. So I'm noticing this pattern. I'm noticing that the figure number and that side of my rectangle are the same. So for figure X, this side of my rectangle is going to be X, right? If I'm looking for figure 100, this side's gonna be 100. Now, if I'm looking for how far across that rectangle is, it is the figure number plus 3, right? 1 plus 3 gives me 4, 2 plus 3 gives me 5, and so on. So whatever my figure number is, I'm going to take that and add 3, and that will give me that dimension of my rectangle. Now, I still have this 1 and this 1 that are always there, okay? So how did I figure out how many boxes there were? Well, I multiplied this to get my rectangle and then added the 1 and the 1, right? So that's what I'm going to do here. The number of boxes in my figure is equal to the dimensions of the rectangle, right? So x times x plus 3. That's going to give me how many squares are in there, just like doing 1 times 4 and 2 times 5 gave me that, right? Then we can't forget about our 1 box and our 1 box, which is 2. So we add 2. Oh my gosh. Now we could leave it like that, but I want to distribute that x in. It'll just make me happy and look more quadratic-y. So that's a word. I'm distributing that x in, so I end up with y equals x times x gives me x squared. X times 3 gives me 3x. And then that plus 2, which represents those 2 boxes. This is the equation, the quadratic equation, that represents these figures. I can now be like, hey, what's the 500th figure if I wanted to? I don't really want to, but if I wanted to, I could plug in 500 for x, and it would tell me how many boxes were in the 500th figure, and I could figure out what it looked like, right? Okay, was that amazing? Tell me it was amazing. All right, I hope this helped. If you need some more videos like this, I will link one for you. Thanks.